Hello, today we're going to talk about the Poisson distribution. And these are the rules that you need to follow for the Poisson distribution. We're going to consider the number of times an event occurs over an interval of time and assume that the probability of occurrence is the same for any intervals of equal length. The occurrence in any interval is independent of an occurrence in any non-overlapping interval. If x is equal to the number of occurrences in an interval, then x is a Poisson random variable. And this is the formula for Poisson. You can also use Excel to calculate. So I'm going to show you both the commands for Excel, and I'm going to show you how to do it by hand. So we're going to go over this problem, and it's similar to the one that's in your homework. It says the number of fatalities resulting from automobile accidents for a 10-mile stretch of an interstate highway averages 1 per 100,000 automobiles. During a particular holiday weekend, 600,000 automobiles travel over the 10-mile segment. So using the Poisson distribution, we're going to find the probability of non-fatalities, three fatalities, and at least one fatality. Alright, so we need to get some information from this problem. And this is the information that I've gathered. We know that 1 out of 100,000 will have car accidents. So out of 600,000, how many car accidents will there be? Okay, so that's what we're trying to figure out. So you can set this up as a proportion. You can cross multiply. You get 100,000 times n is equal to 600,000. And then to get n by itself, you just divide both sides by 100,000. And I get n is 6. So basically, this is our average. So you know what? I'm going to change this to mu, because mu means average. So it'll work in the formula. So the average number of fatalities out of 600,000 automobiles would be 6. All right. So in this problem, we want the probability that there's no fatalities. So let x be equal to 0. We're going to plug everything back into the formula. So we go back to the formula. We have x, in this case is 0, and we have the mean, which is 6. So all we have to do is plug these numbers back in. So let me rewrite it so it'll make sense. This is what we're trying to find out. And I'm going to plug everything back into the formula. So this will be e to the negative 6 times 6 to the 0 power all over 0 factorial. So let me rewrite the formula so you can see how we plugged it in. This is x, this is mu. So this would be mu, negative mu. This would be mu to the x, and this would be x factorial. So that's the formula. I just plugged the numbers in. Now you can do this by calculator or you can do it by hand. On your calculator, you should have an E button. It should look like this, e to the x. So you can calculate it that way. Once you get that, you multiply it by 6 to the 0 power. Any number raised to the 0 power is 1. Okay? 0 factorial is always 1. So these two things right here would just be 1. So basically the only thing you really need to know is e to the negative 6, and you can do that on your calculator if you have that command on your calculator. Alright, the Excel command is this. The Excel command is always for an exact number. This would be x, this would be mu, And then this is whether or not you want it to be cumulative. Cumulative means if you have a less than sign, less than or equal to sign. This is when you will use cumulative, would be set to true. If you don't, if you just have an equal sign, cumulative will be set to false. So that's why I have the word false here. So when I did it by hand, I got 0.0024. And you're going to get the same answer when you do it in Excel. So the probability that there's no fatalities is 0.0024. So now we want to figure out the probability that there's 3 fatalities. So basically we want this, the probability that X is 3, exactly 3. So we plug it back into the Poisson formula. My X is now 3, the mean is still 6. So now I'm just going to plug it back in. So I got e to the negative 6 times 6 to the third power all over 3 factorial. You can, like I said, you can just punch it in a calculator. You have to be careful with the calculator because sometimes it doesn't understand the order of operations. So make sure you understand how your calculator works. To do it in Excel, it will be Poisson is equal to equal Poisson 3, 6, and false. Okay. And when I did it in Excel, I got 0.089. Actually, I did this by hand, but Excel gave me the same answer. So the probability that you get exactly 3 fatalities is 0.089. And the last problem says the probability of at least 1 fatality. So in this one, you want X is greater than or equal to 1. Now you can do this by hand, but it's going to be long because anything that's greater than or equal to 1, you got to go out. 1, 2, 3, 4, 5, and so on. But this is the same as saying 1 minus the probability that X is less than 1. It's the same concept. So now you can do this by hand. This is much simpler because you don't have that many numbers to deal with. So if X is less than 1, that's just the same as saying X is equal to exactly 0 because the only number less than 1 is 0. So we've already calculated the probability that X is exactly 0. We got it as 0.0024. So we just need to subtract that from 1. So when I subtract it from 1, I get 0.9970. So the probability that you get at least 1 fatality is 0.9970. Okay? So hopefully this will help you with the other problems on how to set them up. Hope this helps.